Hey everyone, and welcome back. Today, we're going to pull back the curtain on a secret conversation that's happening inside your PC right now. It's a dialogue that pretty much controls everything you do, from gaming to the massive world of AI. So let's jump right in.
You know that feeling, right? You've got a beast of a machine, top of the line, everything. But then you're in the middle of a game or some heavy-duty work and it just stutters. It's super frustrating, and the reason why it happens probably isn't what you think.
See, it's not always about raw horsepower or the clock speed of your chips. It's about communication. The real slowdown, the real bottleneck, is often the clumsy conversation happening between your computer's two most important components. And today, we're going to figure out why. Okay, so to really get this, you've got to think of your computer as having two very different brains. Let's meet the stars of our show.
So on one side, you've got the CPU, or the host. Think of it as the brilliant do-it-all manager of the entire system. And on the other side, you have the GPU, the device. This is like a massive, hyper-specialized workshop with thousands of workers all doing the same repetitive task at once. It's perfect for things like graphics and AI. Sounds like a dream team, right? Well, not exactly.
Here's the problem. This supposed dream team has a huge communication issue. It's like they work in two totally different buildings, and this creates something we call the Great Memory Divide. And this is the absolute core of the issue. The CPU has its own memory, the system RAM, and the GPU has its own separate, dedicated video RAM. They're like two separate islands. So for the GPU to actually do anything, the CPU has to literally pack up all the data, put it on a boat, and ship it over. And this is what that process used to look like. I mean, just look at how clunky this is. A programmer had to manually reserve memory on both islands, manually copy the data from one to the other, wait for it to travel, let the GPU do its job, and then manually copy the results back. It's this insane five-step dance for every single task.
Now, the slowest part of this whole journey is the boat, or in our case, the PCIe bus. That's the physical connection between them. And you really should think of it like a narrow, one-lane bridge connecting two massive, bustling cities. It's a natural choke point. And this chart really puts the problem into perspective. The GPU's own internal memory is ridiculously fast, but that PCIe bus, it's crawling along in comparison. This creates a gigantic bottleneck, where your super powerful GPU is just sitting there, twiddling its thumbs, waiting for data to arrive from the slow bridge.
So, how do we fix this mess? Well, some really smart engineers came up with a brilliant idea. What if, instead of two separate islands, both brains could just work off of a shared workspace, like a magic whiteboard they could both see and use at the same time?
And that solution is called Unified Memory Architecture, or UMA. Basically, it creates a single shared pool of memory addresses that both the CPU and GPU can understand. It's like they're finally speaking the same language, looking at the same map.
The absolute best part of this, the whole process of moving data around is now automatic. That clunky, five-step manual dance we saw earlier, gone. The system takes care of it behind the scenes.
Just look at the new workflow. The GPU just asks for the data it needs, and if the data isn't already there, the system just zaps it over automatically. It's that simple. We went from 5 complex manual steps down to 2 simple automatic ones. This is a total game changer for developers.
But you knew there had to be a catch, right? This magic whiteboard isn't a perfect solution. As it turns out, there's no such thing as a free lunch, and there are some hidden costs and real-world limits we have to talk about.
Because while the software got a whole lot smarter, the physical hardware is still the same. That PCI bus, our bridge with the speed limit, it's still there and it's still the same width. Unified memory is like a brilliant traffic cop, but it can't magically build a bigger bridge. This fundamental hardware limit is what people call the PCI wall. And if you're not careful, you can run into a nasty situation called thrashing. This is what happens when your program needs little bits of data from all over the place, causing the system to constantly shuttle data back and forth over that slow bridge. It gets stuck in a loop, and your performance just absolutely plummets. So here's the key takeaway. Unified memory is fantastic because it hides the complexity of the data transfer, but it can't hide the physical cost. Every time the system has to automatically move data, it triggers something called a page fault, which basically puts the GPU on pause while it waits. A few of those are fine, but too many and your whole program grinds to a halt.
Okay, so why does any of this techie stuff actually matter to you? Well, because this internal conversation is at the very heart of modern computing. It affects everything from how smoothly your games run to how fast the next generation of AI can learn. For any developers watching, or if you're just curious, optimizing this conversation comes down to a few key ideas. You want to minimize how often you cross that bridge. Keep data on the GPU as long as you can. Group a bunch of small transfers into one big one, that's called batching, and you can even use advanced tricks like pinned memory and prefetching to give the system hints about what you'll need next.
And really, that's the bottom line. The next giant leap in computing performance isn't just going to come from making faster chips. It's going to come from teaching those chips how to have smarter, faster, and more efficient conversations with each other.
So, I'll leave you with this question. As AI models and video game graphics get more and more demanding, what do you think the next big breakthrough will be? How are we going to get our computers' two brains to talk to each other even faster? Thanks for joining me.